Hello sir, my name is Krishnendu Paul, second year student of Electronics and Communication Department. Today I am here to present my project on analog communication waveform visualization toolbox. This interactive toolbox helps students visualize and understand different analog communication modulation techniques such as AM, FM, SSB-SC, PM, DSB-SC, PM, PWM, and PPM in real time. The main objective of this project is to make analog communication concept easier to understand through graphical visualization. User can change signal parameter and observe how the waveform spectrum and demodulated output change. First, here I am selecting a standard AM. Then when I change the amplitude, it changes its amplitude, and if I change frequency, it changes frequency. And now if I play this simulation, then we can see the simulated graph here, where in this is input signal, this is modulated channel waveform ST, where if I pause it, this is the blue line is for message signal, and the red is for carrier signal. If from here, if I change the amplitude of carrier signal, then we can see we can see in this visualization the red signal changes amplitude, and here modulated channel waveform are changed according to this amplitude change. And if I change the frequency, as you can say, it changes frequency. And we also say demodulated recovery output and frequency spectrum analyzer. Uh, mm, Now if I change frequency, then it changes frequency. Now if I change the modulation index, then we can see it's change its envelope with change the modulation index. Now for FM, now I am selecting from FM. This toolbox is very useful for the student who want to visualize the waveform of analog communication system. Here user can select anyone from this, and after that when he try to change the parameter from here, he can change it. Now, for FM, if I change the amplitude, it change its amplitude. If I change frequency, it also change frequency. And for carrier signal, same. And we can see here the modulated channel waveform changing according I change the amplitude and frequency also. Now, if I change the modulation index, then it also change according this. Also, I have noise level and the RC time constant here. And now, if I change it, if I stable the noise and play it, we can see also the simulation, and anyone can watch it in pause. Now, for AM over modulation, AM over modulation. Here, if I play it and change according to the user input, change according to the user group. For amplitude, when the amplitude is 0, it show like that. And this is the overall simulation here. For DSB-SC, I select now DSB-SC. In this technique, the carriers is suppressed and only sideband are transmitted. The improves power efficiency. This improves the power efficiency. The recovery use current detection to recovery the original signal. Here we can see the simulation. Also for SSB-SC, so single tone. For SSB-SC single tone, same we can see here the visualization, and user can change this input and check the waveform pattern. And now for the pulse sampling, now I will select this pulse modulation technique by changing the sampling frequency. By changing the sampling frequency, is changed changing the sampling frequency is change it. After that, I add a noise channel. Add a noise channel using the noise channel slider. The effect of noise on the transmitted and recovered signal can be observed directly from selecting this. This helps. This overall project helps the student understand the practical communication system of analog communication subject, and it is very useful for the student who want to visualize the all waveform uh, he which are he study in class, uh, and if he use this toolbox he can uh, very easily see the visualization of the signal. Thank you.